Hi, myself Merle and Peter. We are going to discuss about the interaction of light with matter, or in other words, interaction of electromagnetic radiation with matter. As we all know, atoms and molecules are characterized by discrete energy levels. The electrons in the atoms make transitions between these energy levels when they absorb or emit electromagnetic radiations. And why these transitions are important? Because the wavelength of spectral line emitted is a characteristic of the energy levels of the atom. And an atom can interact with the electromagnetic radiation in three different ways. They are absorption, spontaneous emission, and stimulated emission. Now we can discuss about these three processes. And the first is absorption. Atom occupying in the lower energy state, which is represented as E1, can absorb electromagnetic radiation and get excited to an upper energy state, which is represented as E2. That is, when the atom interacts with the electromagnetic radiation, energy is absorbed by the atom from the electromagnetic radiation. Then the atom's energy will increase. Then it cannot remain in the lower energy state, but it will get excited to the upper energy level, which is represented as E2. And if nu is the frequency of the incident radiation, then E2 minus E1, that is the separation between the energy levels E1 and E2, will be equal to h nu, where nu is the frequency. And the rate of absorption is given by RAB is equal to B12 into rho of nu into N1. From the equation, it is clear that the rate of absorption depends on two factors. They are rho of nu and N1. That is, the rate of absorption depends on the number of photons per unit volume incidenting on the atom and the population of atoms in E1. These are the two factors on which the rate of absorption depends. And here B12 is called the Einstein's absorption coefficient, and it gives the probability of transition from E1 to E2. And the second process is spontaneous emission. An excited atom without the influence of any external agency undergoes transition to lower energy state by emitting a photon by itself. We know that the atom in an excited level is having a very short lifetime. During this short lifetime, if the excited atom is not stimulated by any external agency, it will undergo a transition to lower energy state by emitting a photon by itself. Because we know that each and every atom have a tendency to remain in the lower energy state or to come back to the lower energy state because it is a stable state. So, if the atom, in the excited atom, without the influence of any external agency, it will undergo a transition to the lower energy state by emitting a photon. And this emission is what we call spontaneous emission. And the diagram is shown. Here E1 and E2 are the lower and the upper energy levels, and the energy separation E2 minus E1 is equal to h nu, where nu is the frequency of the emitted radiation. And the rate of spontaneous emission is given as RSP is equal to A21 into N2. That is, the rate of spontaneous emission depends on N2, which is the population in the excited level. Here A21 is called the Einstein's coefficient of spontaneous emission. And the spontaneous emission is completely random in direction. So the emitted light is incoherent in nature. And the third process is called the stimulated emission. If a photon of energy h nu is equal to E2 minus E1 interacts with an excited atom, the atom can undergo transition to lower energy level with the emission of another photon. That is, after stimulated emission, there will be two photons, that is, the incident photon and the emitted photons. So here, a photon is forcing the excited atom to undergo a transition to the lower energy level. So it is the process of forced emission of photons by an excited atom due to the influence of an external agency. That is, the photon which is forcing the excited atom act as the external agency. And thus the rate of stimulated emission of photon is given by RST is equal to B21 into rho of nu into N2. That is, here the rate of stimulated emission depends on two factors, that is the population of the excited atoms in E2, that is represented as N2, and the number of photon per unit volume of the incident beam, which is represented as rho of nu. And B21 is the Einstein's coefficient of stimulated emission. And since the transition is from the second E2 to E1, it is represented as B21. Now the characteristics of stimulated emission. Stimulated emission is coherent with the incident radiation. That is, the incident photon and the emitted photon propagate in same direction. They both have the same frequency and they have the same phase or constant phase difference. So the stimulated emission is said to be coherent with the incident radiation. And an important feature of stimulated emission is the multiplication of photons or the amplification of light. How this amplification of light is taking place? One photon induces or forces one excited atom to emit another photon, and thus two photons are produced. And these two photons induce other two excited atoms to produce two more photons, and this process continues like that, and thus light gets amplified, and this will have high intensity too. So the stimulated emission is the principle behind the operation of lasers. And this is a diagram which is representing stimulated emission. And in the first energy levels we can see a photon interacting with the excited atom, and thus the excited atom comes back, or it will make a transition to the lower energy levels, and finally two photons are liberated after the transition from the higher energy state to the lower energy state. The emitted photon is coherent with the incident photon also. That's all about stimulated emission. So, we were discussing about the three different ways in which an electromagnetic radiation can interact with matter: absorption, spontaneous emission, and stimulated emission. Hope you all understood the topic. Thank you.